Hello, how are you? What are we studying in this unit? Of course, global warming, right? So today, shall we study the natural global warming first? Yes, of course. So today, let's study the natural global warming, okay? Then let's start with the heat balance on Earth. So what is this? This is the heat balance on Earth. The heat comes from the sun, right? The sun. So incoming solar energy is 100% here. And then 6% is directly reflected by the atmosphere. And then about 20% is reflected by clouds, okay, by these clouds. And then about 4% is directly reflected by the ground and the ocean, okay, the surface of the ground and the surface of the ocean. So the surface of the earth, about 4%, right? So totally 30%, right? Okay, totally about 30% is directly reflected, right? Reflected. So not absorbed, right? So 30% is not absorbed. But some are actually really absorbed, right? So for example, this about 19% is absorbed by atmosphere, and about 50% is absorbed by the ground, right? No, by the surface, actually including the ocean, okay? So by land and the ocean, absorbed about half, right? About half is absorbed by the ground, by the surface of the earth, okay? And then this absorbed heat, okay? So it's kept in the atmosphere, or say on the surface of the earth for some time, right? For some time, and then slowly, okay, it is radiated. So the energy radiates out into the space. This is 50%, right? And this is about 20%. So the sum is about 70%, right? So this 70% of the heat slowly, okay, radiates out of the earth, okay, into space. So totally about 70, okay, 6% is radiated from the surface, and 64% radiates from the atmosphere. So in what of form? In the form of what? In the form of infrared radiation. Okay. So any warm stuff, any warm substances or objects, any warm objects, including your body, because your body is warm, right? Temperature 37 degrees Celsius. So so any warm stuff can radiate infrared radiation. Got it, right? So because the air here is warm, and the air of the floor or the ocean is also warm, okay, compared to the really very cold places, right? So the warm stuff, the warm substances can radiate the infrared radiation. Okay, infrared radiation is the heat. Okay, the infrared radiation carries the heat. Got it, right? Okay, so the heat is slowly sent out into space, and this is 70%, right? For 64 plus 6%. Okay, so actually 30% plus 70%. So actually 100%. So all the energy in is equal to all the energy out, right? So for this entire Earth, the heat is in balance, right? So the heat is in balance here, and then the temperature of the Earth as a whole, the average temperature of the Earth should be kept at a constant number, right? Okay, so that is a good thing, right? I mean, for the entire world, the temperature, the average temperature should be kept as a constant, and this is a good thing, right? Because we do not want drastic change. So any sudden change of the temperature can cause disasters, right? So we don't want that. We want a constant average temperature. So that's good. Why the temperature on Earth is relatively constant? So this means in the day the temperature is not very high, so it is not too hot, right? In the day, and in the night it is not very cold, right? So it is because of the greenhouse effect of the atmosphere, right? So we have the atmosphere to protect us. On the surface of the moon, okay, in the day of the moon, or in the day of the not Venus, right? Mercury, the planet Mercury, you know. In the day there, the temperature is very high, right? Hundreds of degrees Celsius. You can be baked into barbecue, okay. And in the night, then the temperature is negative 160 degrees Celsius, right? And then you can be frozen into crystals, okay. So those places are hells, right? And our Earth is paradise, right? Okay. Because of what? Because of the atmosphere. So our atmosphere has the greenhouse effect, and then it protects us. And this also can also explain why June is not the hottest month in the year, and December is not the coldest month in the year. Got it, right? How come? Why does the atmosphere has the effect of greenhouse? Because in the air there are greenhouse gases. Okay. Let's read these words. You know, the air, the atmosphere, the greatest, the major gas is nitrogen, right? 78%. And the second one is oxygen, right? Okay, 21%, right? And the rest, only 1%, right? Okay, the sum of the rest is only less than 1%. Okay, but the greenhouse effect is from these two gases? Actually not. So let's read these words. Okay. Nitrogen and oxygen are very poor absorbers of infrared radiation because they consist only two atoms. Okay. So actually these two gases, they are not the greenhouse gases. Okay. The others are the greenhouse gases. Water, okay, this is water, right? Carbon dioxide, this is carbon dioxide, and methane, okay, this is methane, right? And actually nitrous oxide molecules, they contain several atoms as well as different types of atoms. These molecules can absorb different types of energy, okay, including infrared radiation. Okay. So when the molecules, the atoms in the molecules begin to what? To vibrate, they have to absorb, okay, infrared radiation. And when they stop when they stop the vibration, then they give off infrared radiation. Okay, and when the molecules rotate, when they begin to rotate, they need to absorb infrared radiation. And when they want to stop rotation, then they give off infrared radiation. Okay, so these molecules can absorb and give off infrared radiation, right? So they are greenhouse gases. Okay, and scientists. Now we come to our real topic, right? The real topic today. So it is the natural climate change, right? So the scientists studied the climate history of the Earth, and they discovered that there were long-term climate changes. Okay, so you can look at this picture, right? This graph. Every about 100,000 years, this is 0, right? From this 0 to 100,000 years, and this is 200,000 years, right? This is 300,000 years, and this is 400,000 years. So every 100,000 years, there is a period, right? There is a cycle of climate change, right? There is a peak and a bottom. Okay, and in between there are also some short-term changes, right? Some short-term climate changes. Okay, so question: what caused these changes, right? What caused these changes in temperature over time? What are the causes? This is the question, right? Okay, scientists brought up some theories to explain such changes. The first is this, okay, the longest, right? So the plate tectonics, right? Plate tectonic theory, or say continental drift theory, can explain the climate change, the local climate change, right? In the long run, right? In the long terms, okay, the long term climate changes. This is a potential factor, right? That can cause the long term climate change, right? How long? How long is the long term? This is the longest, right? Because this continental drift takes millions of years, right? So this explains the change over the millions of years. And a second reason, or say factor, that can cause the long-term climate change may be this. I said may, right? So this is just a theory. A theory may not be absolutely correct, right? Okay. The Earth's orbit actually is changing. It changed once every about 100,000 years. So this explains the climate change of the cycle, the period of about 100,000 years, right? The orbit changes. Okay, the Earth's orbit changes. Sometimes it is such a oval, and sometimes it is such a flatter oval. So the eccentricity changes. Okay, and the axis of rotation of the Earth also changes. So this is called precession. Okay, so the axis of the rotation of the Earth currently, or say now Now it is pointing at Polaris, right? But sometimes, we say after tens of thousands of years, in about a few dozens, actually, in about dozens of thousands of years, the axis of rotation of our Earth will not be pointing at Polaris, okay? But this is also what? This is also periodic. So after about 100,000 years, then it will again point at Polaris again in the future. Okay. So such changes can also cause the climate change in the long run, actually. So how about the short-term climate changes? Because we also saw, so a few minutes ago, right, we saw the graph. There were some short-term climate changes, right? Okay. What can cause the short-term climate changes? You can also bring up some explanations, right? So for example, this volcanic eruption can cause some climate change over, for example, a few decades, right? And then how about this the periodic activities of the sun. So this is a sunspot, right? Okay, the activities of the sun is also actually periodic. It changes. So if the sun gives off more heat, then of course our Earth has a higher temperature, right? And if the sun in some years it gives off less energy, then of course our Earth has lower temperature, right? Okay. And then how about this El Nino? You know, the El Nino also has a period of a few decades. Okay. So El Nino, you know how the El Nino is caused, right? That is usually the ocean current in the along the equator. I mean, in the Pacific Ocean, it is from the east to the west, right? But sometimes the wind can disappear for a short time. Okay, and then the water accumulated here can flow backward, right? And when the water flows backward, then it also carries, because of friction, right? It also carries the air. So the flowing air is the wind, right? So the wind is warm and moist. So warm, moist air carries much rain to this west coast of the South America, right? Usually the coast of the South America, the western coast of the South America is usually dry and cold, right? But sometimes due to the El Nino, due to this El Nino condition, this place will be warm and rainy. So such climate is bizarre, right? Such phenomena is bizarre. Okay, and you are able to explain such bizarre phenomena, right? Okay, good. So these are some of the factors that cause the short-term climate changes, right? Okay, these can be the factors. Okay, and then there may be some other factors. So for example, this is a positive feedback loop. Okay, positive feedback loops can amplify the effects. Okay, they can amplify the effects. How? So what is positive feedback? We need to explain this, right? So for example, we use an example. This is an example of a positive feedback. So for example, this albedo effect. So now we need to learn a word. Albedo is a name of a person actually. So the scientist studied this first. So this phenomenon is named after him, and then this is called albedo. What is albedo? Albedo means the reflection of the ice of the surface of our Earth. Okay. So albedo reflection is higher here, right? Reflection is higher here because the ice is white, and the albedo here, the reflection here is low, right? Because this color is dark. Okay, so the albedo is 0.2, and the albedo here is 0.72. So this means 75% of the light is reflected, and here only 20% is reflected. Got it, right? Okay. So here less is reflected, then this means more is absorbed, right? Okay. Here more is reflected, then less is absorbed, right? Okay. So how this is related to the positive feedback, and what is the positive feedback? Positive feedback is this. Okay. So first, if the global warming causes the melt of the melting of the ice, then what will happen? Then it becomes dark, right? Then the surface becomes dark, and then less sunshine is reflected, right? So more is absorbed. So this will cause higher temperature on Earth, right? So it is hotter, and then the melting is quicker, right? It's faster. Then if the melting is faster, then lower albedo, right? Then higher temperature, right? So what does this mean? Then this means the condition is worse and worse. Or say the temperature on Earth is higher and higher. Then such feedback is called positive feedback. So this means more and more, higher and higher. Then it is a positive feedback. So what is a negative feedback? I use an example. An example in your house, in your home, then that is a negative feedback. The thermostat. So for example, if temperature is too high, then the thermostat can stop the heating. Okay. If the heating is stopped, then your house will not be too hot, right? So if it cannot be more and more, if it can be kept at a constant rate, can be kept at a constant level, then it is called negative feedback. If the condition becomes worse and worse, or more and more, then it is a positive feedback. Got it, right? Okay, positive and negative feedbacks, you can tell the difference. Okay, now we come to our final topic. That is how to study the past climates. Because I showed you the graph of the history of the long-term and short-term climate change of our Earth, right? The question is, how did the scientists know that, right? How did they know, right? They can know the ancient information in many different ways. Okay, this is a way, right? You can see some pictures, the pictures drawn by ancient people, right? So you can at most you can know at most thousands of years old, right? So for example, the ancient not this picture, I mean, for example, ancient Aboriginal people in North America, they drew some pictures on the rocks, right? Okay, in the caves, and then you can check the caves, and if you watch the pictures, some of the pictures might give you some information, right? So for example, this is a ancient European picture, And then from this picture, you can know that ancient Europe was very cold, right? Okay. And then you can use tree rings. Okay, these are year rings, right? Okay, from this year rings, from the thickness of the year rings, you can know the information about the ancient climate. And a very old tree can live for thousands of years, right? So you can know the information thousands of years ago, right? So for example, this year, because the year ring is very thick, so this means in that year the climate is very good, right? It was very good, warm and rainy, right? Otherwise, it could not grow so fast, right? So for example, this year must be a bad year, right? Okay, so you can know some information from the year range of an old tree. And you can also get information from the Arctic or Antarctic ice. Okay, you can from the ice, deep ice, you can get the trapped air bubbles. And if you study the composition of the air and compare it with today's air, and then you can know the difference, and you can infer some information about the ancient climate. Okay, and this you also can study thousands of years old climate, right? And you can also study the coral reef. Okay, the coral reef. Okay, you can also know information thousands of or hundreds of years old. And you can also study the sediment. Okay, below. Okay, below under the ocean bottom. Okay, the ocean floor. Under the ocean floor, you can dig some sediments. Just like this, you dig some sediments and you can study the composition, and then you can also get some information about the ancient climates, right? By this method, you can get information how many years old, maybe millions of years old, right? Okay, at least hundreds of thousands of years old. And then these are the stalactites and stalagmites. Okay, by studying such stuff, you can also know information how many years old, maybe sometimes millions of years old, right? Okay, so this is also a good method to study. Okay, so actually today we just study so much, but we need to summarize. Let's do some summary. Let's summarize. So what are we studying in this unit? Actually, in this unit, we just want to study this debate. Actually, the debate. So the first question is the world getting warmer? So this means global warming is real or false? Is true or false? Global warming is true or false? This is the first question, right? Is the world really getting warmer? Second question is, if it is really getting warmer, then is global warming caused by humans? Right? This is a second question, right? And then finally, if it is caused by humans, then the question, what are the solutions? Okay, so should humans change our lifestyles to reduce carbon emission, or not necessary, right? So actually in this unit, we just need to study these big questions. Got it, right? Okay. If yes, then congratulations. Okay, good. Okay, thank you. Good luck. Okay, thank you. Bye. Have a nice day. Bye.